Unit 9A is all about the graphs of sine and cosine, and we are going to spend a lot of time this unit actually graphing the trig functions. But for today, we're just going to focus on what the general properties of sine and cosine curves. This focuses on learning targets 1, 2, and 3, finding amplitude of a sinusoidal function and describing its relationship, finding the period of a sinusoidal function and describing its relationship, and finding the frequency and describing its relationship. So those are three vocab terms that are new to us. So let's start off just reviewing what sine and cosine are all about. So if you see here, graphed in red is our sine function. It's one of our 13 basic and hopefully one that you recognize. You'll notice that the y-axis is labeled in units of 1 and that the x-axis is actually labeled in units of pi over 2. You've got pi over 2, pi, 3 pi over 2, 2 pi. Those represent the angles that we are used to seeing in degrees at every 90, but now in radians. And this is the standard format of what our graphs will look like this unit. Take a second, put this on pause, and think about what all of these properties are as you go down. The one that we do not know about yet is this periodic wave, but try to think about what that would actually mean. Once you've paused and thought about these things, then move on to see the answers. Okay, here we're going to look at the cosine function. Again, notice our graph is in the same general shape, this time with a maximum when your angle is 0. Again, take a second, pause, think about what all of these properties are of the cosine function, and when you're ready, hit play again to see the answers. Okay, that should have been sufficient for a recap of what the sine and cosine curves are. Any function is considered a sinusoid if it can be written in this general form. Sine and cosine curves are both considered sinusoids. You'll notice that we just use the general sine curve here, but you could rewrite cosine in terms of sine anytime you want. So we think about our function as a multiplier, a times the sine of b times the quantity x plus c, and quantity plus d. A, B, C, and D are all constants, and neither A nor B can be 0, because if you multiply anything by 0, you get 0, which would make our function essentially non-existent. Okay, we're going to talk about what these properties mean, what A, B, C, and D do to the function. A, C, and D are all things we talked about already in Unit 8. B is something new that will be introduced. We're going to start off by talking amplitude. That's A, amplitude. Half the height of the wave. So how high it goes from the midline. The normal amplitude of a sine curve would be 1 because it goes up to 1 and down to -1 from that middle centered line. Amplitude is found by taking the absolute value of A, so whatever number is out front. So a normal sine curve is 1 times sine of x, which makes its amplitude 1. If you put a different number out front, it does that vertical stretch, which would give you the new amplitude. What happens if A is negative? Well, we know this again from Unit 8. If A is negative, it's a negative outside the party, and it will reflect over the x-axis. So the first few examples actually ask you to find the amplitude and just describe its transformation. Number 1, you'll notice that there is no number out front, which really means that it's a 1. 1 times cosine of x is going to mean the amplitude is 1. And since it's just normal, there's going to be no transformation from original. In B, you've got 1/2 sine of x. The 1/2 out front is going to cause a vertical shrink times 1/2. And that vertical shrink is going to cause, my K just doesn't want to write, does it? Vertical shrink times 1/2 is going to cause the amplitude to now be 1/2. Okay, so we're looking at a graph that is now half the height that it used to be. Part C will be a clicker in class tomorrow. The next thing we're going to talk about is B. B affects the period of the function. So in those first few slides, you saw that that cosine and sine are periodic functions. A period is the length of one full wave of the function, how long it takes from start to finish. Period is found by taking 2 pi divided by the absolute value of b, that b being part of that original equation. Well, 2 pi comes from the fact that the original functions, sine and cosine, both have a period of 2 pi. So either sine from midline up to midline down, or cosine from its maximum to another maximum. So one full wave is 2 pi for both of those. So the B inside is the one part that last unit we didn't get a chance to talk about, and it causes horizontal stretch or shrink. So you calculate period by doing 2 pi divided by absolute value of B, which means that the horizontal stretch or shrink factor is going to be found by taking the reciprocal of B, because you are dividing by B instead of multiplying. What happens if B is negative? Well, that means the graph will reflect over the y-axis, because again, you'll have a negative inside. Find the period of each and describe the transformation is this next set of examples. Again, we start with the basic, where we have 1 sine of 1x. So our B value is 1, which means our period is going to be 2 pi divided by the absolute value of 1, which just gets you 2 pi. This is going to mean there is no transformation from the original. In example B, you'll see that we now have several things happening. It starts with actually asking us to find the period. The B value here is what's inside being multiplied by x. There's really a 1 in the numerator. So our B value is 1/5. If we go to find period, we use our formula, 2 pi divided by the absolute value of B would be dividing by 1/5. If you flip and multiply, that's going to get you 2 pi times 5 over 1, which means your new period, not 11, 1, your new period is 10 pi. What that did was stretch you horizontally times 5. So you've got a horizontal stretch times 5. In other transformations from out front, your negative out front will be a reflection over the x-axis. And the 2 out front is going to mean a vertical stretch times 2. Okay. Example C will be a clicker tomorrow in class. Frequency comes next, and frequency also deals with B. So the period is how long it takes to complete a function. Frequency is the number of waves that you complete in any given interval. So it is related with the period. Frequency is found by actually the reciprocal of the period, taking the absolute value of B divided by 2 pi. So these examples ask you to find the frequency and describe its meaning. Again, identify the B value, because that's what we need. Again, we have 1/5 here. So we now have 1/5 divided by 2 pi, which is going to get us 1/5 times 1 over 2 pi, which gets us 1 over 10 pi as a final answer, as our period. This describes the number of waves in an interval. So graphically, what this means is our graph will complete one wave per 10 pi of length. Okay, so I have to go 10 pi for x before I complete one wave. Example B, I have a B value of 4. So I'm going to take the absolute value divided by 2 pi. That's going to get me 4 times 1 over 2 pi, 4 will reduce to a 2 when it cancels with the 2 in the bottom. You end up with 2 over pi. Graphically, what this means is 2 waves per pi in length. So this time I've got 2 waves every pi. So my normal is 1 wave per 2 pi. So this is increased dramatically.